Hello and welcome to our webinar today on object storage for M&E, managing the expectations of free storage and accessible archives. This webinar is for JB&A, and if you have any questions, feel free to follow up with your JB&A representative. My name is Adrian Herrera. I'm the VP Marketing for Caringo, and I have with me Tony Barbagallo. Tony, why don't you say hi?
Hello. Hi there. I'm the VP of Product at Caringo. I manage product management and product marketing. So work with Adrian on creating the sales tools, product positioning, all of the collateral that you guys will need for selling Caringo Swarm, positioning it, competitive analysis, etc.
And let's go ahead and get started. So obviously I take what Tony creates and package it up so that you have everything you need to sell object storage. Again, if you have any questions after the webinar, just go ahead and feel free to reach out to your JB&A rep, or you can go to caringo.com and get some information. We have a lot of what we're going to share in the M&E section under solutions. So let's go ahead and get started. Setting the stage. Everyone expects nearly free storage and instant access to their assets, and it's going to get worse. So we see these two macro issues as a challenge across the board in the M&E space. And the question is, can you make storage a competitive advantage while optimizing infrastructure operations and workflow? After this webinar, you'll have your answer, and spoiler alert, the answer is yes. And JB&A and Caringo are here to help. We're going to walk through this information. We're going to take a very high-level look at object storage as a technology, where it sits in the M&E workflow. And if you have any specific questions, just follow up with us directly. But first, let's give a really quick overview on Caringo. Why Caringo? Who is Caringo? Well, we're object storage experts. We've been doing it for over 12 years. We've always focused on storage software. We're enterprise ready. We have a number of customers across many industries. We have some very highly secure deployments, all the way to some more web scale kind of front end user generated content use cases, and everything in between. And the reason organizations are using us is really because of this one phrase here. In today's world, data is not deleted. Enterprises and consumers alike just aren't deleting anything anymore. I mean, if you just kind of take a look at what's going on in your personal life, all the photos and everything that you capture on your mobile device or your cell phone, how often do you go in and delete those photos and delete that information? You don't really delete it anymore. Even your email is archived. It's not really deleted anymore. And we're seeing this across the board in just about every M&E use case. And it's leading to these great expectations. Organizations are now expecting free storage and instantly accessible archives. We see this, quite a bit in the production and post-production space. So a lot of the production houses that we speak to have their customers, whether they're the studios or some other content creators, that expect all of the projects that are being worked on to be instantly accessible at any time, and they don't really want to pay for that storage. We have other organizations in the M&E space, some of your web scale companies, your front-end applications, those working on user-generated content, who store users' content, whether it's photos or video or anything that's user-generated. And they have to do that in a very cost-effective way because they have an ad-based or a freemium aspect to their site or subscription. So they need to provide storage at a very low cost and provide instant access in a way that performs to a user's expectations. Because if they don't, those users will just go somewhere else. So we're really seeing this great expectation issue across the board in the M&E space in just about every workflow and application. And the issue is, well, we have all these traditional technologies. You know, I've been using my NAS, I've been using my CDN, I've been using all these things, all these different types of technologies. You know, why now is there an issue? You know, why is this more challenging, and why are these traditional technologies falling short? And it really has to do with what's on this slide. So Tony, you want to walk everyone through this?
Yeah, and I think, Adrian, when you talk about free storage, and you touched on this, but I think we're really talking about, we're not talking about the storage that the organizations are using, that the production houses are using for collaboration, for their transactional processing, for their rendering. We're really talking about the studios wanting their assets stored indefinitely, and they don't want to have to pay for that. We've talked to a number of production agencies that have said that that doesn't even come across in the contract. It's just an expectation that the studio's assets will always be available. And what happens there is when we look at these traditional technologies, and again, we're talking about the archive, or as we like to call it, active archive, because our data would be instantly accessible in Caringo Swarm. But the traditional technologies that fall short, we've heard that a lot of production houses and other organizations are using tape. And I don't know if those tapes go in a shoebox, or maybe they go into a tape library, but you still have to actually go through the exercise of finding the right tape, finding the right data, loading the tape, getting the data off of the tape, etc. And this is where a lot of traditional technologies in this regard do actually fall short. And on the storage side, we're really talking about performance and scalability, and not only scaling up of, say, a file system, but to be able to scale out as I continue to get this non-deleted data that I have to save. Multi-tenancy to allow multiple people at the same time to access data. Again, if you're using a tape-based archive solution, that could be somewhat problematic, especially if your tapes are residing in one part of the company's infrastructure, maybe one part of the campus, and someone else is off-site or remote, to be able to get to that data. There's also power and cooling that enter into the equation in terms of storage, and protection, which we'll talk about in great detail coming up. But that's talking about the protection of the video assets, or any of the assets. How are they backed up? How are they stored? And not only that, how are they protected both from accidental deletion as well as hardware failure? So in terms of access, I touched on this a little bit, but we're talking about access from not only internally on laptops and desktops, but also over the website, via web portals, perhaps via mobile phones, iPads, etc. So all of these things enter into the access equation, as well as applications that may need to access data in a certain way, either through projects like Avid, through general file systems, and those are all different ways to access the data that all enter into the equation.
Yeah, and I guess you bring up a lot of good points. You know, with these traditional technologies too, you know, it's really the consumption patterns of these users that's identifying or really exposing the shortfalls in these technologies, right?
Right.
Because as they demand more ways to access, and as they demand just really instant access of what used to historically take a long time. I mean, think about, you know, binge watching. Before, you know, production companies, they had, you know, many weeks to months to produce a show, and now they have to produce a whole season, you know, in a very short time frame, and after the fact, you know, continue to provide access to all of that content, really in perpetuity. You know, there never is Netflix or is HBO ever gonna, you know, take Game of Thrones off of HBO on demand? You know, I don't think so. You know, they're always going to keep that up. So, you know, it's the changing in consumption patterns, and the fact that all of these consumers really expect convenience, and it makes it very difficult for IT staff and IT execs to support all that. And so, you know, why don't you walk everyone through the storage options that they have today?
Sure, and I'm actually going to take a right to left approach on this slide. So I'll start with block. And block is typically was the first actual access to data on storage medium. Typically, the access to block storage is through an application like a database, modified but optimized for performance. So you're looking at transactional databases, et cetera. And then what is typically used in the block-based category is a specific client application with an OS, fixed system attributes, again, transactional data and optimized for performance. It's very limited, obviously, if you're going to a block-based architecture to the applications that can access that data. And that's really why the whole notion of file systems came about, which was a nice abstracted way to get to the block-based data that's on the storage media. So when I think of files, we're talking about, of course, Word, Excel, anything that runs inside a file system, understands folders and subfolders and the files that reside in the file system. Now, the limitation of a file system, while it's great to scale up into a particular server, file systems are very difficult to scale out. They have a limited number of indexes that you can see inside the file systems. For us consumers, we typically don't run into those limitations on our laptops or desktop. But if you're talking about storing hundreds of thousands or millions or even billions of pieces of information, that will quickly saturate the file systems that are in use today. So that's really where the file systems fall short, and that's really why object storage has become so popular, especially in the cloud, and also more and more popular on-premise as an archive solution, because object storage can be very easily and seamlessly scaled. To scale an object storage environment, typically you add a server or multiple servers into a flat address space, and your storage grows. So there's no worry about mount points or silos of that nature. And you can think of object storage, if anyone's familiar with like NoSQL databases, as a key value pair. You have a key to the object, and the object just resides out there somewhere in the storage environment. In order to find that object, you just need the key. The other really strong advantage for object storage, especially in the M&E space, is the ability to add custom metadata to the object. And that's a very key point. Typically on the file systems, the metadata that can be added are just notions about what the file is, the file type, where it resides, how large it is. With object storage, I can add virtually any piece of custom metadata. Of course, you have the digital asset managers that are attempting to do this as well, to be able to run in a file system environment. But again, you still run into the limitations of silos and how do you scale out the file system hardware as your needs grow and you start to get into the multiple terabytes and petabytes of data storage needed.
Yeah, and a great analogy for object that you and I like to use, Tony, is the car valet, right? You get a valet ticket, you give the attendant your car. You don't really care where they park it as long as there's no scratches, there's no issues to it. When it comes time to get your car back, you give them your ticket and you get your car back. And that's really the difference between file. In file, you need to know where it's parked, the exact location to go back and get it yourself. And it's a very high level. It's a high level analogy, but it's similar. It's the ease of content access that really allows for a lot of automation on the back end, and part of that automation has to do a lot with protection. So do you want to walk people through both of the high level types of protection?
Sure. And typically in an object storage environment, there's two types of protection. Replication, whereby you're simply creating replicas. And by the way, when we talk about protection, we're talking about protection from hardware failure on site. In Caringo Swarm, I can also replicate all my data offsite to another cluster, and that can happen automatically behind the scenes. So there's really no need in Caringo Swarm for any kind of third-party backup software. So there's a cost savings in and of itself. But in terms of replication, that's a simple notion of creating copies of an object or a file, so that if a number of nodes goes down, hardware failure, disk corruption, or whatever, you still have the file remains still available. Parity-based is really a notion of what's called erasure coding. Many of you that are familiar on the hardware side with RAID, it's similar to RAID, but it's all done in software and on a per object basis. So, you know, with RAID, you can lose a certain number of drives, and then you can rebuild the RAID array to get all your data back. With parity-based error correction in an object storage environment, you do something similar. You have data chunks and parity chunks, but those are then segmented across various nodes in the storage cluster by the storage operating system itself.
Yeah, and so we've covered protection, we've covered the different types of storage, architectures available, and all the issues associated with storage and access. But let's start driving into the M&E data center, because we see a lot of, you know, the M&E industry or you know, everyone in the workflow. They have very specific applications, and they enable those with a wide range of storage technologies. So do you want to walk everyone through this, Tony?
Sure. And again, very high level. At the top level, you have your editing platforms, you have your DAMs, other specific applications, devices, not only for access, but perhaps for recording and playback and content delivery networks, again, at a very high level. And then from a storage infrastructure standpoint, you have what we would call your primary storage, which could either be a storage area network or network attached storage devices, could even be direct attached storage to very powerful servers. Tape libraries, other tier 2 storage for either cold storage or archive, including disk, as well as on-premise cloud storage, cloud and object storage like Swarm, and then of course cloud storage as a service, which one could utilize for either disaster protection site if you don't want to maintain a separate off-site location for your data yourself, or to leverage some of the services that are coming out by the cloud storage providers like facial recognition service, other business intelligence services that can be run on the data.
So the question is, you have all these different types of storage technologies. You know, where is the opportunity for object storage? And it's really, you know, to either eliminate or optimize those 4 boxes that are behind the blue box there. So your type libraries, your tier 2, your disk archive, and of course your on-premise cloud and object storage. So that's the opportunity for object storage within the M&E data center. There are some use cases where object storage may be used for certain NAS use cases or workflows, but there may be some performance or some file locking requirements that object storage may not fully satisfy. But you know, needless to say, you know, those 4 boxes, tape library, tier 2, disk archive, and on-prem cloud and object storage, that's where the majority of the unstructured data is sitting in the M&E data center. And the reason why object storage is such a great solution for a lot of the significant storage and access issues across those tiers is because it brings infrastructure, operational, workflow efficiencies that no other storage technologies bring. And in fact, it's almost a misnomer to call object storage just storage, because there's data management, content delivery, and a lot of different functionality that comes along with a lot of different solutions in the market. You know, specifically, you know, here's the value that Caringo brings. And we reduce storage TCO by 75% in a software package that takes standard hardware, creates a massively scalable pool of storage that's always available, that is always protected, it self-protects itself, self-heals itself. There's universal support for file and these new modern and cloud-based use cases, and we'll go into that in a bit. And there are some compliance and multi-tenancy and search features built in. So all of this is in a software package that you can install in your own data center. It's really taking a lot of the technology and the experiences that were learned in the cloud storage space, bringing them to you within your own data center. And what Tony and I are going to do now is we're going to walk you through some of those efficiencies, pointing out the common value that object storage brings, and then also going over some of the unique values that Caringo Swarm brings. So here, infrastructure efficiencies, object storage brings massive cross-site scale commodity. They can install on commodity hardware. It's already pre-installed in commodity hardware. For object storage vendors, a lot of them are software. Most of them are software-based, but like ourselves, we also have a hardware or server device if you'd like to have a fully complete solution. And you can support any network. So these are values that all object storage solutions provide. Now, Tony, Caringo Swarm, we bring some unique infrastructure efficiencies. You want to walk everyone through those?
Sure, and one thing to point out is we are truly software-defined storage. There are products out there, Lattice comes to mind, where while it is software, it's sold almost exclusively with hardware, and typically you're starting at a petabyte and moving upwards from there. Our software-defined storage, as Adrian says, will run on any mix of storage hardware, 2 or 3 nodes to start, any size of storage capacity. So we can go as small as a few gigabytes. Perhaps that's not the most efficient way to use an object storage environment, but you get the point. We can literally start very small and grow to multiple petabytes from starting with that just small footprint. And the way we can do that is either by adding nodes or by scaling up the disk drives, the disk capacity within a server. Couple of other unique features with Swarm is the fact that we actually boot from bare metal, and this is key. We are a true software appliance, and what that means is there is no requirement on the end user for Linux distribution to actually run any kind of operating system on the server before sending it into the storage cluster. And what that allows us to do is really make efficient use of the disk capacity for end user storage. We only take up 3 to 5% of the total disk capacity in a server. Typical object storage environment takes a solid 20% of the data storage for running the object storage software. And that's because it's typically running on a Linux operating system, which requires that amount of space for file system journaling, etc. We've actually built our own file system from the ground up, and we run in RAM. So again, we're not taking up that precious storage space. On the performance, oh, sorry, go on, Adrian.
Oh no, go ahead.
I was going to say, from a performance standpoint, our performance in our solution actually increases as you add nodes. You're adding CPU power to the cluster, which increases both throughput and in terms of read-write gigabytes per second.
And so, I mean, you've covered everything from a drive utilization. This is just to get the software to run and to store content. An industry-leading 95% drive utilization, but you also have the benefit of the different protection schemes when compared to traditional technologies like RAID, correct? So
absolutely,
there are significant savings, and while still maintaining the durability that you get with RAID.
Yeah, and you can see here a quick comparison. We have RAID on the far left, which again, it always been a traditional way to protect data against hardware failure, and specifically disk failure. So you have RAID here, RAID 5.1, but you can see the amount of usable storage you get versus the amount of overhead. It's about half for RAID 5, again, because you're using that Linux file system that's taking up some space as well. Obviously, that's a little bit better than using replicas, But that is one way to add speed. We have organizations that use multiple replicas so that they can decrease the latency of access, especially in a content delivery type of use case. And then finally, we have erasure coding, which I mentioned before. In this case, erasure coding, we're saying erasure coding 10-2, which means 10 data bits and 2 parity bits. So I could lose 2 nodes and still maintain my integrity of the files. And you can see here the amount of overhead, very small amount of overhead for erasure coding, which when you start to get up into the hundreds of terabytes and petabytes, this really starts to matter.
Yeah, and then you have a lot of the operational efficiencies that object storage brings. So, again, these are commonalities across object storage solutions. The ability to manage a tremendous amount of storage with very limited resources. So, one sysadmin can manage 20 petabytes of data. You have built-in protection. Even though all vendors say they have built-in protection, there are different approaches, and Tony will walk you through those in a bit. And then you have multi-tenancy, so the ability to support different domains, different buckets, different users, different use cases, all on the same infrastructure, all using the same infrastructure. So those are commonalities across object storage solutions. But Tony, Caringo Swarm has some pretty unique benefits from the operational efficiency perspective, correct?
Absolutely, and I mentioned already the ability to boot from bare metal. I mean, you can literally scale a Swarm storage cluster in minutes. Take a new server out of the box, set it up to boot over the network, turn it on, and our storage operating system will just boot into the RAM on that device, and you're off and running. Everything else happens behind the scenes. Load balancing of the cluster, moving data over to the new storage node, etc. You can retire nodes in much the same way. All the load balancing happens behind the scenes automatically by our storage cluster. One of the other interesting and unique advantages to Swarm is I talked about the replication and erasure coding. You can actually change erasure coding for a particular object on the fly. You can change it based on bucket, based on individual object. You can have replicated objects and erasure coded objects within the same bucket or domain. These are all very unique capabilities to Swarm. Now, we talked about the parallel architecture, and Adrian mentioned hassle-free management. Again, add to the fact that you don't have any separate database for the metadata or having to deal with Linux distributions, and we could truly realize the goal of having just one system admin for that much storage under management. And finally, we talked about wanting to be able to consolidate a lot of tier 2 architectures, and tape is very popular. One of the things we've patented as well is a notion of darchive, and this actually allows us to spin down drives with the data on them that hasn't been accessed. So we're talking about electrical savings in terms of power consumption as well. That is all an inherent part of the storage operating system that we provide.
Yeah, and so all of these things in play, we actually have a customer that has a very large video library. I believe they're exceeding 7 to 8 petabytes now. And they're using a lot of the features that Tony has covered to act as an extended warranty. So they're not renewing the warranty when the warranty on their servers expires. They just run them into the ground and add new servers, and taking advantage of the boot from bare metal and the built-in protection, they know that their content is always going to be accessible. And along with that comes the time to recover. They're able to take that advantage and use us as an extended warranty because recovery is always happening. And here, Tony, we're showing the difference between replications and erasure coding on object and cloud versus RAID. And I think on the RAID side, you do have some vendors claiming that they have very fast RAID recovery times. But why don't you walk people through the difference on cloud and object and traditional storage?
Yeah, and again, in Swarm, we from a time to recover standpoint, time to recover is quicker when you have more nodes in the system, because all nodes in the system participate in recovery. Our health processor actually checks in the background for bit rot, so you don't have to worry about reading a file and then finding out that it may be corrupted and has to be rebuilt. We do all of that in the background. In terms of, as Adrian mentioned, some vendors talking about really being able to reduce the recovery and rebuild time for RAID, but you're throwing really expensive SSDs at this solution, which is thereby increasing the costs pretty significantly, especially if you're talking about more of a tier 2 or archive solution. You really don't want to have SSDs, expensive SSDs in the mix that are ultimately going to fail after a certain amount of reads and writes on those SSDs. So those are all things to consider when we're talking about recovery time, and not only time to recover, but the trade-off between time and cost.
Yeah, and it's interesting. With RAID, with these SSD-based solutions, those are really optimal for small data sets, correct? But as data sets increase, normal kind of thinking, you would think, well, as my data sets increase or my cluster increases, everything's going to take longer to recover, right? Well, that's not the case with object storage. And do you want to explain why, Tony?
Yeah, and for us, obviously, if you're going to add more capacity, you're typically going to add more nodes. That's the best practice in terms of increasing storage size in an object storage cluster. And when you increase those nodes, as you can see here, you have more processing capacity that can be applied to a recovery. Whereas, again, in a typical RAID environment, you're really talking about that rack of RAID drives, and that's what's responsible for the rebuild. Adding more storage nodes to a RAID-based environment is not going to increase, or is not going to decrease recovery time.
Yeah, so I guess that there's two things going on. You have the increase in available resources to help you out to recover quicker. And then you also have the unit that you need to protect getting smaller. It's the actual object, or it's the specific erasure coded segment. So you combine both of those, and as a cluster increases in size, you really start to get the benefits of scale and the parallel nature of the architecture.
Right.
And this is why object storage is so great for very large scale asset libraries, in addition to a high amount of files. So if you're struggling with hundreds of thousands of files to billions of files, object storage, and specifically object storage solutions that leverage parallel architectures, are really the only ways to solve those issues.
Mm-hmm.
And that brings us to workflow efficiencies. So really starting to get into the heart of how object storage, and specifically Caringo, plugs into the M&E workflow. From a high level, all object storage solutions out there have file and web interfaces. You'll also hear hybrid cloud a lot. A lot of object storage solutions now have a hybrid cloud feature. Parallel upload and read access. So the ability to read within a specific file, or upload a lot of files at the same time, or deliver a lot of files at the same time. And custom metadata, the ability to add metadata. Even though all the solutions out there support adding of metadata, there are different approaches as far as metadata databases and that kind of thing that Tony will walk you through. But Caringo, again, we bring some very unique workflow efficiencies that give a lot of value to users out there. So why don't you walk everyone through those, Tony?
Yeah, and I think probably the biggest one is a universal namespace, whereby we could actually ingest files via NFS, read them out through a web portal via S3, make modifications to those files via the web portal, see those modifications come through to NFS, and not only the file data themselves or the object data, but also the metadata. We can actually change metadata, add metadata to files via NFS, and again, see all that metadata, search on that metadata from within our environment via S3 or via our own content portal. We've also added capabilities around compliance. And again, this is starting to become, security and compliance are starting to become, hot items in the M&E space. But we allow for write once, read many, so that files and objects cannot be modified once written. Legal hold, integrity seals, and basically audit trails, so we can see who's accessed, who's modified files. And again, as Adrian mentioned, we have a complete integration with Elasticsearch. So we have a fully customizable search capability of the metadata. We can create collections of objects based on a metadata search, and those can be actually dynamic collections, so they can change as data is added and accessed. So for instance, you might have, say, some video surveillance data, and I want to just only look at the last 24 hours or only look at the corporate headquarters parking lot. I can do that very easily without having to know where that data is stored in the object store.
So, we're going to jump into some very specific scenarios in the M&E industry with M&E workflows. The first is enabling interoperability between all the different applications that organizations use. And specifically through an integration with Marquis broadcast. So here at the top you have your editing platforms, your asset managers, your cloud-based services, and the question is, how do you make data and the different projects and the different content you have in each one of those applications interact with each other, and furthermore, how do you move them from different types of storage media? And Marquis actually does that media management for you while preserving the project architecture and structure. And Caringo will just plug in. Let me go ahead and do that again. So you see your tape library, your tier 2, your disk archive, your on-premise cloud storage can all be either reduced, optimized, or eliminated with Caringo Swarm. And Tony, there's a few different ways on how we do that, not just with Marquis, but with others, correct?
Sure. And S3, which is the protocol that Amazon created to access their Amazon Web Services environment, has become really the de facto standard for communicating not only to back-end cloud environments, but also to other back-end storage environments. We're seeing now some of the tape vendors adopt S3 so that they can be back-end targets. We've had S3 capability since 2012 and continue to maintain that compatibility and capability with Amazon. And so with us, Marquis has recently added S3 as an integration capability, so for the back-end targets like Swarm. But we also have a product called FileFly, which plugs directly into the Windows file system, and that's how we first started working with Marquis. So from an application standpoint, the Marquis Project Parking doesn't see anything different about the data that is stored in Windows. Behind the scenes, our FileFly migrates that data, leaving pointers behind, migrates that data to Caringo Swarm on the back end. When those files are accessed by Project Parking, they're seamlessly moved back in from Swarm into the primary storage. What that allows is that I don't have to keep all of this potentially archived data in primary storage just so that I can use a product like Project Parking.
And I think it's important to point out, for all the use cases that and all the scenarios we're walking through, you can use the exact same storage and the exact same infrastructure.
Right.
You don't need to set up unique devices for all of these different applications. You can leverage the same disks, the same drives, the same servers, for all of these use cases at once.
And based on our multi-tenancy capabilities, separate those on domains with privileges and access as well.
Yeah, and the next scenario is direct access from asset management solutions. So in the M&E space, you are dealing with asset management solutions, and here are just a few of them that we're certified with, but we really support everyone that supports S3 integration right, Tony? I mean, you've had some experience with certifications out there, correct?
And actually, pretty much out of the box. Reach Engine's a great example. We were on the phone with an introductory call with one of their developers, and on that call, we actually gave him some credentials to our test lab. He input those credentials because, again, they support S3 with the notion of targeting AWS as the back end. But with our S3 capability, they simply plugged in our credentials, our servers and tokens, and it just worked right out of the box.
Yeah, and that's with any S3 application also. So it just doesn't have to be asset management solutions. Pixit is kind of an HSM solution, but you also have a number of different applications out there like CyberDuck and S3 Browser and other types of applications that you may use that can plug straight into Caringo Swarm. So even though we're focusing on asset management solutions, there's a lot of different applications that are enabled by the S3 API.
Absolutely.
And here are scenario 3, back-ending a CDN for origin storage or OTT. And I think this is kind of traditionally where object storage really started to become common in M&E data centers. So it's always interesting that organizations may not know about object storage, but I guarantee you've used object storage because it backends every major cloud storage service out there. And the reason is you can deliver directly from the storage layer. And there's a Caringo customer, NEP, and they use Caringo Swarm as a foundation for their content delivery network. And you can see their high-level architecture here where they have 2 data centers and they have some web servers and load balancers in front of Swarm. The reason they have some additional infrastructure is because they're using us to power some very popular video services in Europe. They use us to power Videoland, kind of the Netflix equivalent in Europe. And they also use us to deliver Fox Sports content and Premier League content. So it needs to be fast, it needs to perform, and it also needs to be economical. They started with just a few terabytes, I believe, 50 to 100 terabytes, and now they're well over a petabyte across a few different sites. And they're able to saturate their backbone, 45 gigabits per second. They could have gone higher as far as from a performance perspective. So it's important to point out that with object storage, you're really talking about throughput or your ability to deliver versus your traditional IOPS or the ability to stitch something together. It's more about delivering content, and that's why object storage is so great to enable a lot of these new use cases that are demanded now by consumers. Cord cutting and video on demand and long tail content. Think about all the user generated content that people are uploading to YouTube, all the how-to videos and all that stuff, all that content. How can you efficiently and cost effectively store that and continue to provide access? Well, the way you do that is with object storage. Do you have anything else to add on this?
Yeah, no, I think you pretty much hit it. And again, you sort of touched on it, but the other beauty of object storage, because it's HTTP based, you can really start to streamline that sort of application server, web server, storage server layer. And that's what a number of our customers have done as well, and just essentially remove a whole layer of hardware infrastructure.
Yeah, and from that perspective, one of our customers too is a very large web scale organization. We can't use their name publicly, but needless to say, they have their peak season around Valentine's. I won't tell you who the organization is, but at least I can say that. Their peak season around Valentine's, and they actually were able to have no downtime because of some of the operational efficiencies and workflow efficiencies they gained by integrating Caringo Swarm. So, everything that Tony went over from a functional perspective combined allowed them to go through their peak season without any issues and eliminate a whole layer of infrastructure You don't really think of storage being able to eliminate an application layer or a database layer, but in this case, they were able to leverage Swarm for those types of efficiencies. So again, it's almost object storage is almost a misnomer. Object storage, and specifically Caringo Swarm, does a lot more than just storage. It's access, it's optimization, it's data protection, it's data management, and everything's wrapped into a software package that helps you manage the expectation of free storage and instant access. And all these things combined are why we say it reduces storage TCO by 75%. So I think more importantly, now that you don't have to really focus on managing storage infrastructure, you're able to assign those resources or deploy them somewhere else, for your main application, whether that's content creation or something else. And Tony, do you have any closing comments or any comments on this side?
Yeah, I was just going to say, and how nice would it be to actually truly have instant access to archive footage when a studio asks for it?
Yeah, absolutely. I mean, be able to make your customers happy, and ultimately that's what it's about. Providing value and also enabling some additional functionality that you may not offer today. Provide storage services, provide ongoing access, and maybe expand your business and your business model. All with the same software and all leveraging commodity hardware. And with that, if you have any questions, feel free to contact your JB&A rep. You can also go to caringo.com for additional information. Again, we have a lot of great information in our M&E section. Tony, do you have any closing comments for the audience?
No, thank you very much for your time and for listening.
Yeah, I'd like to thank everyone else. Again, like Tony said, thank you for your time. Thanks for listening. This concludes our webinar.